Today we will start with lesson 8, which is talking about binomial distributions. In this lesson, we will learn how can we find the binomial probability and how to use the binomial distributions. Now, let's now come back to the probability. Let's leave the statistics. Let's now learn here how can we find the probability of an event that they have only two possible outcomes. Things that if you make it, you have fail or success, like a win or loss. This is an event, or these are an events that have only two possible outcomes. In this lesson now, we will learn how can we find the probability of these two possible, or these two types of events by using something we called it binomial probability. Now, before we're talking about them, what is the binomial experiment? The binomial experiment, it has some features. One of them, that the trials must be independent. The trials are independent. So I am not talking about an dependent events. I'm talking about independent. The second one, each trial has two possible outcomes. As I told you, win or loss, success or fail. So any trial must have two possible outcomes only. Independent, two possible outcomes. The third one, we have a fixed number of trials. Like I repeat the events 5 times, so I have a fixed number of trials. And the last one, the probability of each outcome is constant throughout the trials. Like, as an example, I decide to bring 3 babies as an example. The probability of the first one that he could be half a boy and half a girl. Now, the first thing, I decide to bring 3 babies. So I have a fixed number of trials. This is the first one. The second one, each event or each trial have only 2 possible outcomes. It could be boy or girl. I don't have either boy or girl. The third one, they are independent. What does it mean? That means if I bring the first one, boy, the second baby didn't depend on the first one. And the last one here, that I have half and half each. I mean, like I have a fixed number in each trial. 0.5 for babies, 0.5 for boys, for girls. On the second trial, I have also the same outcomes. The last one, I have also the same outcomes. So they have to be independent. I have only 2 possible outcomes. I have a fixed number of trials, and the probability is constant throughout the trials. These are the features of the binomial experiment. Let's take an example here. Now, recall from lesson 11.4 that you can use a tree diagram to find probabilities. Here also we can use the tree diagram, Now how to use the different outcomes and probabilities for the basketball player shooting 2 free throws. Now, here we have basketball players. He shoots, or he make 2 free throws. So the first one, he makes 2. So let's look at the first shooting. The first shooting, he could hit, he could miss the loss. Or he could hit a goal, or he could miss a goal. The second trial, he could hit, he could miss. He could hit, he could miss. So, what does it mean? That's mean he could hit the basketball 2 times, so the probability is hit, or he could hit and the second one he could miss it. He could miss it, the first one and hit the second one, and he could miss both of them. Look at them here now. We have independent events because the first one didn't depend on the second one, or the second one didn't depend on the first one. The second thing here, they have two outcomes, hit or miss. The third one, we have a number, or we have a fixed constant probability. What does it mean? Here now, they told me that it is known that this player is a good shooter. So he have hit about 90%. So that's mean the probability of hit is 0.9. So the probability of miss, it will be 0.1, because as I told you, they have to be summation of them. They must be 1. And also, since we have a fixed or constant probability, so here also it will be repeated. Like 0.9 hit, 0.1 miss, 0.9 hit, 0.1 miss. This is, we call it binomial distribution. They are independent. They have 2 possible outcomes only, and the probability of each outcome, since it is repeated, must be the same. Is it clear?
Yes.
Yeah. Yeah.
Okay. So here, as you see, we have the tree as I drew it before. So now, so I told you the possible outcomes. We can have hit, or hit, miss, or miss, hit, or miss. Now, what is the probability that he get the two shooting are, or the 2 shots So what is now the probability that the 2 shots here are hit? I will look at here now. I want to see where are they hit. Where are they hit? This possible, this one only, or this branch only. So I will say they are 0.9 times 0.9, which is 0.81. Now, the possible of at least, or you can say 1 hit, of 1 hit. 1 hit, what does it mean? That's mean one of them, it could be hit and miss, and the second one miss and hit. Where are they? Let's see here. They are here.
Teacher, they say just 1 hit. It means like just 0.9.
1 hit and 1, so at least 1 hit. So that means the second one will be miss. Where we have to find this? It could be hit, miss, or miss, hit. Here, one of them is hit. How to find the probability now? To find it here, they told me that you have to multiply 2, which is, since we have 2 paths, you can say, or 2 branches, Then we have multiply 0.9 times 0.1, which is 0.9, the probability of pass or hit, and 0.1, the probability of miss. And later on, I will give you a formula to solve it. But here, just to understand how to find it from the tree. Now, the last one here, I want to find the probability of zero hit. Zero hit, what does it mean? That means both of the two shoots are misses. So we say that we have only this one. So I have only one branch. So I write 1 times 0.1 times 0.1 or 0.1 squared. So that means
What do you mean about zero?
Zero. Where's zero? Zero hit. That means there's no hit. He didn't hit. Or he didn't make a shot.
Oh, okay.
So at both the two trials, we have misses a shot. Now, as an example, if I told you now find the probability of at least one hit. The probability of at least one hit. What do we have? We have the probability of one hit only and two hits. I told you to at least give me what is the probability that they at least make one shot. They told me we have the probability of one shot and we have the probability of two shots. Of one shot, which is 0.18, of two shots, which is 0.81. So since he is a good player, so the probability of getting one hit at least is 0.99. Now, let's see now the formula here. The formula to find the binomial probability. Let's see what is it. We'll say that the probability of finding x with x independent and independent trial with a constant, with a constant probability and with a fixed number of trials, and we have an what also and so on. So if we have a probability of, since it is independent trial, now we will say that since we have only two outcomes, the probability of pass the outcome, we write it as P, and the probability of failure, we write it as a Q. Like win and loss, boy and girl, like this. Of pass, we write as P. Of fail, we write it as a Q, where P plus Q must equal 1. Okay, how to write it now? First, if I told you now, what is the probability of getting 4 hits from 5, as an example? You have to write it as C of 4 from 5. Then you have to write P and Q. Then above B, you have to write 4, the probability times 4, and the probability of failure times 5 minus 4, which is 1. So the probability or the binomial probability P of x, it will be the combination of x from n times the probability to the power x times the q to the power n minus x. How to find it? Here, the probability of x, you will say that it is the combination of 4 from 5, and the probability of pass, which is b, you have to write it to the power 4, and then here you have to subtract 5 minus 4, you get 1, it will be q to the power 1. So to find the binomial probability, you need to know what is p, what is a q, and how many trials you have to take from the fixed trial. Let's now have these examples here. But before we solve it, did you understand now what is the what is the formula that have to use to find the binomial probability?
Yeah.
Okay.
Teacher, we have used this one before when we talked about Pascal's triangle and stuff, this rule.
Yes. Today I will tell you how to use the binomial distribution to find like x plus y to the power 9.
Yeah, we have took that last year, I remember.
Yeah, they told me that you took it in chapter 5, I think.
Yeah, but we didn't take
Yes.
the same formula.
Yeah,
But-
no, we took this formula. It's kind of different. It's not the same one. It's slightly different, but we took it.
Yeah.
We used it to find like what is that term, like the third term, if we expand the binomial.
We will talk about it today.
Are we going to take it again?
Sorry?
Are we going to take it again?
Yes.
Okay.
Now, let's start here. Let's use a formula to find the probability. Let's have an example here. As a part of a promotion, a store is giving away scratch of cards. Each card has a 40% chance of awarding a prize. So here we have scratching card. When you scratch it, you can win and you can lose. So from this one here, since we have a scratching card, we have 40% of win and a number of percent to loss. So I'm talking about binomial distribution. So they told me now a chance of awarding a prize is 40%. So we have to find P and we have to find the Q. This is the first step. Where is P? It is 40%. Now where's the Q? I didn't written, but I know that P plus the Q must be 1. So it is 0.6. So the probability of win is 0.4. The probability of loss is 0.6. Okay, this is the first step. The second one, suppose you have 5 cards. Now imagine you have 5 cards. So they are independent. Why? Because I have the first card. If I scratch it, I could win. When I scratch the second one, I could lose. When I scratch the third one, I could win, then win, and so on. So is the probability of getting lost in the second card depend on the first one?
No.
No, it doesn't mean when I scratch the second card, I say, okay, I win in the first one, so I will lose now. No, they are independent events. In other words, like there's a mom want to have 5 babies. The first baby is a boy. The second baby is a girl. The third one is a girl. Now let's see that. So the fourth baby will be boy because she bring a girl in the third one.
No.
No, we cannot guess. They are independent. We have 2 probabilities here, boy or girl. So they are independent. They don't depend on each other. So here we have 5 cards. In each 5, we have to scratch it to find if we have win or we will lose. So we are talking about now 5 possible outcomes.
But teacher,
Yes.
teacher, for the card, if you choose the other one, then like the card you are talking about, how it's not dependent. Because there are two possibilities. So if you choose the first possibility, then you have a possibility to get the second one.
Sorry, I didn't understand. You have 5 cards.
Teacher, I mean like how they are not dependent, because if you choose the first card, then you have a possibility to get the second card, you know? Like, I mean, if you have a boy, then the second possibility will be a girl in this card.
No,
So how they are
I
not
told
dependent?
you, I'm not talking about in this trail, in one trail, in 5 different cards. I mean that you have these 5 cards. Okay, you scratch the first one. You find win, as an example. خلاص, now you throw it in the garbage. You have to open now the second one. When you open it, you have 2 possible outcomes: win or lose. You could win also. You now scratch it. You throw it in the garbage. Now you have to open the third one. On the third one, does it mean that if you win at the two first times that you have to lose now?
No, but if it was one card, it will be dependent, right?
Oh yeah, if I am talking about, as an example, one card only, and I told you now, I take win. So what will be the second one? You will tell me it is lost because they are already taken. I'm talking
Yeah.
about only one trial, but here I'm talking about 5 different trials. I scratch the first one, I throw it in the garbage. I didn't repeat it. I will take now a new card. I will scratch it. Then I will take the third card. I will scratch it. So each events in each trial didn't depend on the first one or on the second one.
Okay, teacher, thank you so much.
Yeah. Fine. So here we say the probability of getting a word, getting a price is 0.4, of fail is 0.6, as I told you. Now suppose you have 5 cards. So we have a fixed number of trials. We have 5 cards. Find the probability that exactly 4 of the 5 cards will reveal a price. Now, some of you, طيب teacher, we talk in lesson 1, find of like this 5, how many 4 cards of, or how many 4 of 5. In lesson 1, we're talking about counting methods. I told you find, like question like it will be find in how many ways that you take 4 from 5. If I told you in how many ways, you say it 4 from 5 without order and permutation with order. But here I'm asking you about the probability. So if I told you what is the probability of getting 4 from 5, you must go to the binomial distribution. Now, so before we solve it here, we have to determine if it is binomial or no. They told me that we have 5 repeated trials or 5 cards. So, okay, we have a fixed number of trials. We have 2 possible outcomes, winner or you don't win or you lose. The third one, we have a constant probability of success, which is 0.4 according to the or throughout the trials, and they are independent. Why? As I told you, the outcome of the scratching the first card didn't depend on scratching the second one. Type. Okay, now let's find the probability. We will say that the probability now of X is C. They told me 4 from 5. 4 from 5. Then I told you now P times Q. Now instead of P, I will write 0.4. And instead of Q, I will write 0.6. Then 0.4 to the power 4 times 0.6 to the power 5 minus 4, which is 1. Then we will find it as we know before. Combination of 5 or 5 from 4 times 0.4 to the power of 4 times 0.6, you will get that the probability of getting exactly 4 cards from 5 is 0.0768. This is the probability of getting 4 cards from 5, where the 5 cards are independent. Each card has a fixed number or a constant number of events, of probabilities. Sorry. Is it clear now?
Yeah. Yes, teacher.
Let's have now another example. What is the probability that the number of cards that reveal a price is with 0, is 1, is 2, is 3, and is 5? Let's now find the probability of 0. So the probability of 0, what I have to do, I will say C of 0 from 5 trials times 0.4 times 0.6, 0.4 to the power 0, and 0.6 to the power 5. Now, probability of getting 1, I have to write 1 from 5, sorry, times 0.4 times 0.6. Now, I will raise 0.4 to the power 1, and I will raise 0.6 to the power 5 minus 1, which is 4. Now, probability of 2, I have to say 2 from 5, 0.4 to the power 2 times 0.6 to the power 5 minus 2, which is 3. Now, probability of 3. What is the probability of 3? I have to write C, 3 from 5, then point sorry. Then 0.4 times 0.6. Now 0.4 raised to the power what? What is the power that I have to raise? 0.4.
5 minus 3.
لا 0.4 to the power 3 and 0.6 to the power
2.
yeah.
2.
Now let's find probability of 5. What do we have to do here now? It is C of 5 trials from 5 trials. Then 0.4 times 0.6. Now then here 0.4 raised to the power
5.
5.
no 0.
Oh, yeah.
5 minus 5. لا sorry 5. Oh. And 0.6 raised to the power 5 minus 5, which is 0. So here's we have the probability of 0, 1, 2, 3, and 5.
Teacher,
Yes.
is this rule from that we took in the previous lessons that when we have independent events, we multiply their probabilities by each other. This rule is basically it, but they also multiplied it by the different number of ways, the combination of ways by which they can happen.
Yeah, that's mean when you talk about the trees.
Yeah.
The tree diagram, yeah. But here we have a fixed number of trials, a fixed or a constant probability. This is the first thing. And we have to multiply by the number of branches, or the number of what we call it here, branches, or مش عارف يسموها نسيت. The number of paths. Now I have here. Let's now do this one here. A calculator contains 4 batteries with normal use. Each battery has a 90% chance of lasting for 1 year. What is the probability that all 4 batteries will last a year? Now look at this question here. There's a calculator. It contains 4 batteries. So we have here 4 trials. First battery, second, third, and 1. Now, they told me that the probability of each battery is 0.9 to pass, and to fail is 0.1. The second one also, the probability of pass is 0.9 and the probability of fail is 0.1. The third one, we have the probability of pass is 0.9 and the probability of fail is 0.1. And the last one here also, we have the same. So we have 4 independent outcome, or 4 independent variables or events. We have a fixed number or constant probability for each trial. We have 2 possible outcomes, so we have to use the binomial distribution. Now, they told me what is the probability that all 4. So I need to find the probability of 4. Of all 4 will last a year. We have all 4 from 4. So we write it as 4 from 4. Then I will continue. Times QP times Q. Now 0.9 to the power what?
4.
4. And 0.1?
0.
0.
0. So you will find the answer now. Yes.
Teacher, anything to the power 0 is 1, right?
Yes. So now let's find
Okay,
the combination of 4 from 4, which is 1, times 0.0 to the power 0 is 1, and 0.9 to the power 4 is 0.6561. So the probability that all 4 batteries will last a year is 0.65% or 65% 100. This is,
Okay, thank
we
you,
call
teacher.
it binomial distribution. Yes. I will repeat now before the period will finish. Here we have 4 batteries. So 4 batteries, that means we have 4 independent variables. The failure or the pass of the first battery didn't depend on the second battery. That's why we use the binomial distribution. Is it clear?